Humans are social beings. Therefore, they persistently seek the company of their own kind. As our civilization advances, telescopes probe deeper into the cosmos to find planets potentially harboring life. The Kepler Space Telescope, even after partial failure, significantly contributed to this search, sending vast amounts of data to Earth. Currently, thousands of exoplanets are considered potentially habitable, though only a handful are relatively well studied. Among these, planets orbiting red dwarf stars, like Proxima Centauri b, are particularly noteworthy. Proxima Centauri, a red dwarf star 4.85 billion years old, is part of the Alpha Centauri ternary star system, located approximately 4.24 light-years from Earth, making it our closest stellar neighbor. Proxima Centauri is about 7 times smaller and less massive than our Sun. 2 celestial bodies, potentially Earth-like, have been discovered orbiting this red dwarf. Proxima Centauri b is the closest to its star and thus the most studied. Why is this rocky sphere the focus of scientific attention, even though we can't directly observe its surface and rely on indirect methods? The question revolves around the habitability of planets orbiting red dwarfs. Many astronomers question this habitability due to the inherent instability and activity of these dim stars. The Goldilocks zone, conventionally defined around these stars, is much closer to the star, raising concerns about the possibility of life developing on the surface of such planets. A major argument against habitability is the intense ultraviolet radiation these stars periodically emit. However, recent American research revealed interesting nuances. Laboratory simulations, replicating Earth's conditions during the early stages of life formation, showed that the ancient radiation levels were far higher than today's. Previously, it was believed that during stellar flares, the ultraviolet radiation from red dwarfs would damage DNA and other crucial biological structures. Furthermore, the proximity to the star causes tidal locking, keeping one side of the planet perpetually facing the star. This results in a relatively immobile core, hindering the generation of a protective magnetic field, leaving the planet vulnerable to bombardment by X-rays, gamma rays, and ultraviolet radiation, the latter being the most dangerous to life. But these are outdated findings. Cornell University astrophysicists, using varied computer models, generated plausible predictions suggesting that even with a thin, oxygen-deficient atmosphere, the radiation levels on a planet near a red dwarf would still be considerably lower than those Earth experienced 4 billion years ago during the early Archaean. The Sun's luminosity then was only 70% of its current value, mirroring the parameters of red dwarf stars. Despite these harsh conditions, life on Earth thrived and evolved. This raises the question of whether increased radiation might not hinder, but rather accelerate the development of life through beneficial mutations. Extremophile bacteria, thriving in Yellowstone's boiling springs and the Mariana Trench depths, tolerate significant radiation doses, although mortality depends on the wavelength of radiation. Shorter wavelengths are more lethal. Life on Proxima Centauri b might have evolved protective mechanisms, much like Earth's diverse biological survival strategies, such as fluorescence in coral polyps. Proxima Centauri b was discovered in 2016. This Earth-like object, considered our twin, orbits its star at over 7 million kilometers, with a year lasting approximately 11 Earth days. Yet, its surface isn't scorching due to Proxima Centauri's low luminosity. The planet receives just enough light to allow liquid water to exist. Proxima Centauri b is therefore not a parched desert or a frozen wasteland. Its relatively moderate temperature makes it vaguely Earth-like. Its parameters also resemble Earth's. It's slightly larger in radius and more massive. If Proxima Centauri b possesses a stable, oxygen-rich atmosphere and water, it could potentially be habitable. However, it's unlikely that large, complex life forms exist there. Life forms, if any, are likely at the bacterial or protozoan level. Recent research suggests that the planet may have sufficient gravity to retain a substantial atmosphere, making the prospects less bleak. Yet, there is alarming news. In 2017, Proxima Centauri experienced an exceptionally powerful flare, increasing its luminosity 1,000-fold in 10 seconds. Had there been any biosphere on the planet, it would have been instantly sterilized, although life might have survived in the oceans. Proxima Centauri also has a companion planet, Proxima Centauri c, but it's considered uninhabitable. It is 6 times more massive than Earth, has a year lasting 1936 days, and orbits far from the red dwarf star, precluding the existence of liquid water on its surface. This makes it an icy, lifeless desert. Therefore, the search for what we hope to find on Proxima Centauri b is futile on Proxima Centauri c. The study of the Proxima Centauri system will undoubtedly continue. Currently, no comparable celestial bodies exist in our immediate vicinity. All other exoplanets are far more distant.